Hi, all of you. Good afternoon. Those who have joined us since yesterday, there is one thing we are doing for the last couple of weeks. We're trying to help you all remember some of the important data facts. So before the class starts, we put up a small flashcard on the screen. I know some of you have not done agriculture topics, but even then, maintain a separate folder, data on agriculture, and write down and try to develop a nice compilation for yourself. So before I started geomorphology, the previous module I was teaching was on agriculture. That's how we have agriculture topics right now. So it's just an experiment I'm running. To be very honest, what will work for you, that I know. But what I do not know is, what are you willing to accept? It's my trial कि something आपको click करेगा, you might like something and move on. Yes, so do this. These are those small, I think it's echoing a bit. So these are those small steps. At the end of 1-2 months, you'll realize that you have compiled quite a bit. Okay? So that's how this screen has those data. And these data is important for GS also. Nidhi, I'll recommend, while you add this to your synopsis, एक अलग से भी data file रखना. You must have 3-4 types of files with you. One should be a file on all data accumulations. Because you have geography optional and we are teaching it some ways, you must have one folder on thematic case studies. You must have one folder on, diagrams. What are the sketches, diagrams, maps of India, map of the world? उसका एक अलग से बनाओ. And as you learn a bit more, you can start, अभी नहीं, it's too early for that, you can start compiling what you think can be good introductions for some topics. क्या agriculture question पूछेगा? I'll play with these 4 types of introductions. And I'll play with these 5 types of conclusions. अगर question population पे है, I will use these 7 types of introductions and 4-5 types of conclusions. But this will come much later, not now. Okay. So abhi I'll suggest you please keep one folder for data also. And those who have done agriculture, definitely you add in your synopsis also. कितना है? 2-3 data ही तो है, not big deal. And अलग से data भी रखो. Chandrika, what was that? Single book for physical geography. प्रॉब्लम क्या है चंद्रिका पता है? आपने जिस कैरियर में हाथ डाल दिया ना, okay, that has 15-20 subjects. The problem is that. Okay. So ये जो idea है, sir, give me one book. Okay. My recommendation is, it's not about one book, it's about the most appropriate one book. Okay. The most appropriate one book for physical geography nahi hai. It has to be geomorphology, Savindra Singh, okay, or climatology and so on. But yes, one book you can have for Indian geography, one book you can have, okay, for human geography, one book you can have for geographical thought. But these topics, they are 3-4 different books. Okay, Chandrika, don't lose sleep on that. Aditi, how long will it take to complete the whole syllabus? We'll try in this lifetime, Aditi. Okay, if I can manage, I'll try. So your foundation course will take you 6 months. Then you need another couple of months of answer writing. Okay? Okay. So yesterday for many of you was the first class. You got introduced to some terms. Let me quickly try and revise for you. So I hope you understand what are rocks and what are minerals. Okay? So most of us, we don't appreciate the fact that rock is not a compound. Rock is a large mass of the earth, and it has lot of variations in terms of what it is made up of. So rocks, these are mixtures. Rocks are aggregates of minerals. They are mechanical aggregates of minerals. And rocks के अलग-अलग types होते हैं. Igneous rocks, sedimentary rocks, metamorphic rocks, rocks which are intrusive rocks, rocks which are extrusive rocks. So all of that in some other context. Okay, so for now, they are mixtures, and rocks are made up of minerals. Because they are mixtures, because they are aggregates, they will not have constant properties. And to illustrate that, I said, think of marble is a rock. And marble varies from place to place. The marble of Makrana is not same as the marble of Jabalpur. It's not same in parts of Italy we find marble. So marble is a rock, but you don't have the same marble everywhere. Why? Because it's a rock, it will not have constant properties. वैसे sandstone कहीं पर पूरा red होता है, कहीं पर orangish होता है. If you go to parts of Jodhpur, it is golden color. Okay, that's why Jodhpur is called as the golden city. It's a deep yellow color. I've never seen that kind of color earlier. But look at the marble, look at the sandstone used in Red Fort. It's red in color. Okay, so it varies. Okay, so you understand this now. The word minerals, I said, is used in two ways. One is minerals in terms of the economic substances that we get from mining. So there are uranium is a mineral, iron ore is a mineral, coal is a mineral, oil is a mineral. Mineral can be even salts as minerals. Okay, so minerals are those. Yes, right, you're right. Even sand is a mineral. Sand is called as minor minerals according to our Mineral Act of India. Okay, so this is a separate idea. Whatever we mine, we dig out, we take from earth is called as a mineral. But यहाँ पर हम mineral, this is in terms of chemical or chemistry and geology की बात कर रहे हैं. Here minerals means they are mostly compounds. Minerals are naturally occurring. Minerals are crystalline. And minerals are inorganic. Inorganic as in they are not sourced from the living things. So in that case, coal is not a mineral if I go by this classification. यहाँ पर हम बोलेंगे coal mineral है. It's a mineral rock. Okay. But यहाँ पर coal mineral नहीं है. Oil भी coal is a rock. If I go by geology, coal एक rock है. It is not a mineral. So this mineral concept is different. So these type of minerals will have proper properties, melting point, boiling point. Okay, they'll have some luster. They will have a certain hardness. Okay, these minerals will have certain structures. They are crystalline. So these minerals is what make up the rocks. Okay, so minerals geological concept में अलग होते हैं. Yes, right, Aryan. Is golden sandstone, correct, okay. Then I said कि types of minerals जो हैं, there are many groups of minerals. Oxide group of minerals, calcite group of minerals, okay, or they can be halides, carbonates, sulfates, sulfides. And we can also have pure metals, like gold jo hai, it's a pure metal. So there are different groups of minerals, but I said I'll focus on silicates, because silicates, they are the more abundant of the earth, and you find more silicates in the outer layers of earth. So that's why I focus on silicates, but baki compounds bhi hai. I gave some examples yesterday. In silicates, I said, you remember, again, quartz, feldspar and plagioclase, orthoclase, biotite, okay, amphibole, pyroxene and olivine. Okay, IPO नहीं करके हम इसको APO कर रहे थे हम लोग, remember? Okay, so amphibole, amphibole. This is pyroxene. This is olivine. Like, you must remember these names. And you know, this is biotite. This is orthoclase. This is feldspar. This is plagioclase. And this is quartz. So these names you must remember. And then I gave you the properties of these minerals. Hardest becomes soft. Lightest becomes dense. Acidic becomes more and more basic. When molten, this is viscous, this is thick. You come towards this. Oh, okay, okay. क्या करेंगे इसका? But ये तो enough नहीं है. ठीक है, और भिजवा दो, then I will. They can. ठीक है, I will tell them first. Thank you so much. This is something that we do इसी time में, in the month of September, October or August में. I just 2 minutes here. And some of you are asking me 2-3 दिन से, so how to prepare for 25 attempt and how to prepare for maybe 26 attempt. I don't entertain these questions in the month of Jan, Feb, March, because that's not the right time to address it. Okay, but this is a critical time for all of you. So what I do is I share a questionnaire for all of you. Questionnaire to know what is your base, what have you done in terms of preparation, what are your strengths and weaknesses. Because those who are preparing for 25 attempt, you must be ready for some things. और अगर वो ready नहीं है, you must go after that very aggressively, or maybe rethink of your 25 strategy. Those who are preparing for 26 and beyond, फिर आपका एक अलग होना चाहिए strategy. You don't have to get into mad rush. ठीक है? So ये जो counseling part है and part of your study, I can only help you if I know who is doing what. Like some of you are in graduation 3rd year. Some of you are starting GS right now. Some of you have done the GS. Okay, अब हम क्या करें? Some of you are struggling with basic readings like NCRTs also. ठीक है? So I tried this. Last time I did it, it was fairly good. I was able to guide about 60-70 of students, and I'm very proud to announce that we had 50 students in our prelims group, out of which 21-22 had qualified the prelims this year. Okay, so if I get time to work on you, I can work on you. Okay, मुझे बट उतना time मिलना चाहिए, and some basics must be done from your side. ठीक है? So I'll share this. There's a QR code which I want your data. Data like आपने GS कब शुरू किया था? कब खत्म हो रहा है? What is your understanding of your writing skills? Can you write well, or you have doubts in writing skills? What is your ability in CSAT? Some of you feel, no, I am confident I can do it. So based on your ability, I'll try putting you in different groups. and then we'll see what we can do. ठीक है? So I'll अभी थोड़ा पढ़ाई कर लेते हैं, then I'll come back and take the data if I can. ठीक है? So let's not distract ourselves right now. Yeah, I have put the questionnaire on the Telegram groups also. वो बाद में कर लेना. अभी let's not get distracted. CSAT का PYQ नहीं देखा है. Okay, मुस्कान देख लो. Okay, अच्छे सवाल होते हैं. ठीक है? Okay, let's get back here. So fine. So these are the minerals and the properties I mentioned. These minerals, these are higher in the silicate component. So any mineral silicate जो होगा ना, उसमें silicon oxide oxygen होगा, plus potassium, sodium. It might also have iron and magnesium. These are the 4-5 things, okay, the minerals will have. In some minerals, this one is more. In some minerals, these are more. Iron and magnesium is more. So these minerals have more of silicate component. These minerals have more of iron and magnesium component. That's the reason why these become dense. We call these as mafic and ultramafic, and we have called these as felsic. एक और term भी है. For these minerals, we also use the term, they are ferromagnesium silicates. And we call these as non-ferromagnesium silicates. They will not have magnesium and they might have very small amount of iron. So we call these as non-ferromagnesium silicates, NFMS, and we call these as ferromagnesium silicates. तो यहाँ पर क्या है? Iron and magnesium is more, the silicate component is less. यहाँ पर उल्टा होता है. यहाँ पर silicate component is more, silicon dioxide component, and iron and magnesium is very small, almost negligible. ठीक है? Just add this to your notes if you can, otherwise no worries. So you know the properties here, okay, which is dense, which is lighter, which is harder. Okay, generally जिसमें silicate ज़्यादा होता है, they will be more acidic, and the compounds which have more of iron magnesium, they are more basic. It's a very elementary idea in science, but maybe some of you don't have that background. No worries, you just remember this for now. Okay, so silicate minerals, felsic minerals, we have mafic minerals. Another name for mafic is ferromagnesium silicates. Another name for felsic is non-ferromagnesium silicates. Okay. Then I gave an idea about the rocks. So basalt as a rock, you understand. Granite as a rock, you understand. And andesite, or maybe let me write in sequence. So granite rock, we have andesite rock, and we have basalt rock. So basalt rock is the mafic type. Basalt rock is the ferromagnesium silicate type. Granite one is the felsic one. Granite is the non-ferromagnesium silicate type. And this is the intermediate one, but more towards granite, more towards the non-ferromagnesium silicates. Okay. So once you know this, फिर आपको property दिक्कत नहीं होगी. Harder, softer, less dense, more dense. When they melt, they are more viscous. Okay. When they melt, they are more fluid. Acidic rocks, these are more basic rocks. So once you know this, okay, then you know that quartz, feldspar, plagioclase, orthoclase, ये वाले हैं. Andesite has biotite and these type. Basalt has amphibole, pyroxene. Of course, I didn't mention olivine. This we have in the rock called as peridotite. I mentioned one more rock, dunite, is found in the deeper parts of the earth. I think these terms are fine, all of you. Any doubts on this? Any doubts on this? No worries. No worries. If you don't join late, no problem. I'm just revising it. Any doubts on this? Okay. So, I hope you remember this table. Okay? So, these are the acidic ones. These are intermediate ones, mafic and ultramafic. The extrusive equivalent, the intrusive equivalent. Okay. इसमें granite, इसमें andesite, इसमें basalt, and this is peridotite. So how I remembered when I started off, I would remember this. कि ऐसा है the key rocks. Okay. So granite is always नीचे. Beach wale are above. So above wale extrusive hai. And this again comes down, intrusive. That's how I remember, and now it's of course there. And iska ek equivalent hai rhyolite. Iska equivalent hai diorite. Diorite is a very abundant rock in the interiors of continent. Continents, remember, are very, very thick. The deeper parts of continent is made up of these type of rocks, diorite, and this has gabbro, and this has comatite. This has comatite. Okay? See, one challenge all of you have is, sir, there are too many facts and too many names. That is because this is where the beginnings are. Okay. Beginnings में आपको नाम बहुत हद तक मैकेनिकल याद करना ही पड़ेगा. Like when I'm starting to teach children, okay, basic language, A for apple is A for apple, memorize it. Don't think too much. B for ball, memorize it. 1 + 1 is 2, memorize it. Okay, 3 × 3 is 9, memorize it. As you grow up, you understand the logic then. Phonetics kya hota hai, what's multiplication table, then you remember better. So for now, even if it means struggle, so be it. Aap yaad rakho isko. Okay, 6-7 facts around properties, names of minerals, and you summarize this couple of times, you will remember. Shouldn't be a problem eventually. Okay, so don't give up on these terms. Now with this, I went into the interiors of the earth. What does the interior of the earth look like? So I said interiors of earth is not one solid rock. Interiors are layered. There are layers of earth's inside. The upper layers are lighter. The upper layers are less dense. As they go inside, it becomes more and more dense. I start from continents to 2.5, okay. By the time I hit the course around 13.5 density. So there are layers mein. We have chemical layering and we have the mechanical layering. When I say chemical layering, I'm focusing on the composition in terms of what rocks, what minerals, okay, and their properties. When I say mechanical, I'm talking in terms of the strength. I'm talking in terms of relative rigidity. So some layers, they combine together, they act as one layer. Okay, some layers, okay, you cannot separate them even if in terms of composition they are different. It's like, say, if I take up this pen itself, okay, although it's plastic, you understand, like bahar ek paint ka coat hoga, then couple of layers inside, but the whole thing acts as one. So if I bend it, the whole thing bends. If I break it, the whole thing breaks as one entity. So when I say mechanical layering, this is based on relative rigidity. In layman's terms, this term basically means something to do with hardness. They're not the same things, But for now, let's take it as this implies hardness. And this implies composition. This implies what minerals, it implies what type of rocks, and so on. So chemical layering mein, we have crust, mantle, and the core. And the crust is of two types, oceans and continents. Mantle, outer mantle, middle mantle, inner mantle. Core is outer core and inner core. I believe those properties you more or less know. Okay, crust. Okay, crust is continent, which is the thicker part. Oceans are thinner. Continents are lighter. Oceans are heavier. They are more dense. Continents are andesitic. Continents are granitic. Continents are acidic. Whereas oceans are basaltic. Oceans are mafic type of rocks, and so on. This is one of the misconceptions we had about the earth. For a long time we thought the oceans are extensions of the continents which have submerged. हमें लगता था ऐसे कि this is the continent और यही continent ऐसे bend हो गया है. Okay, and this is the continent here, and I have got water here. We thought that the ocean that we have, they essentially are the continents which have for some reason become a basin and water is accumulated. Now we say कि नहीं, ये wrong concept है. Okay, the floor of the oceans in terms of composition are very different from the continents. So in reality, these are two different type of rocks. The origin also different. So this is the ocean floor. Water may be here. Water is here. So this part of the ocean floor maybe is part of the continent. Otherwise, the ocean that we actually have, this is a different in terms of its properties, its origin, and how it behaves. No, oceans do not have. Ocean crust does not have andesite, Gurmeet. Ocean crust को basalt ही बोलो, and इसमें मेरे साथ bargain मत करो कि थोड़ा तो होगा सर. Okay, सर थोड़ा सा हाँ बोल दीजिए. Okay, so that bit of bargaining goes on. मेरे टीचर ने कहा था है, ठीक है. So there's difference between the ocean crust and the ocean floor. ये दो अलग चीज हैं. Like say this part of the ocean is ocean floor. ये भी ocean अंदर पानी के अंदर ही तो है. This ocean floor is yes part of the continent. What I call as continental shelves. What I call as continental slopes. When I say ocean crust, उसका यही meaning है, nothing else. Ocean crust is always basaltic. Ocean crust has a different mechanism of how it has been formed. ठीक है? So I believe this is okay, all of you. And then you know the rest. The inner core, outer core difference क्या है? The outer core is very hot. The outer core has loose electrons. The outer core is also molten and it is circulating. The inner core is solid, iron rich, nickel rich. And this arrangement where we have got a fluid outer core with moving electrons and inside जो कि iron rich है, this arrangement creates the field of Earth's magnet. So some of us have done a bit of physics to understand this, right? Anything, अगर iron core है and you have an electric field moving around it, it will create magnetism, what we call as electromagnets. You heard about what's called a solenoid. ये term सुना आपने? Solenoids. Solenoids are essentially a bar of iron around which you can wrap some copper wire and you pass some electricity. You pass electricity in this. Okay, and with this, what will happen is this will behave like a magnet. Okay, this is the rule that we have. Yes, wire must be wrapped around it. Correct. So वैसे ही सोचो that there is an iron-rich core inside, and around this there is electricity moving. Why? Because electrons are moving. So it behaves like an electromagnet. Correct. That's the source of Earth's geomagnetism. Outer core is fluid. Yes. Fluid का एक special condition है, which is plasma. When I say plasma state, I basically mean something where the electrons have become loose and they are moving. That's why it's a fluid, but the special fluid condition is called as the plasma condition. Okay, so you understand this. Then you moved on towards the mechanical differentiation. Mechanical differentiation is a lithosphere, asthenosphere, mesosphere and barysphere. हमारे लिए ये important है. The rest you can ignore. Where we say the lithosphere is the uppermost layer. Uppermost layer which includes the crust, there is continents, there is ocean. Okay, these together along with the part of the upper mantle, along with part of upper mantle. Okay, this whole thing is the lithospheric layer up to a depth of approximately 100 kilometers. So this is the continental crust, this is the oceanic crust, this also is the oceanic crust, this is the upper part of the upper mantle. Ye pura acts like one layer. Like even if the compositions are different, the whole thing is, ye pura lithosphere jo hai, ye relatively cold hai, ye relatively hard, and it is rigid, it is brittle. What's the meaning of the word brittle? Something which is very hard and can break. Like glass is brittle. Compare glass with mercury, which is denser. Which is denser, glass or mercury? Mercury is dense, but mercury is liquid. It is not rigid. It's possible for something to be dense but soft. Where glass halka hai but hard, it will break. Okay, so this layer is a light layer, but it is a hard layer. It toot jata hai. It breaks. That's how the blocks called as lithospheric plates. And this is above a layer called as the asthenosphere. This whole thing, ye pura part is upper mantle. Okay, and this is the crust. But the lower part of upper mantle, up to a depth of 400 bolo, 300 bolo kilometers, this is called as the asthenosphere. Asthenosphere has a very high concentration of the mineral called as olivine. यहाँ पर भी olivine है, okay, but this has more amount of olivine. Okay, and this olivine has a very special type of property, which is it is capable of getting deformed when you apply pressure on it. So semi-molten is basically a convenient term for us. We don't have another better word, because for our mind, when I say solid, it's a hard substance. I said, imagine something like jam or jelly or jello, which is hard in terms of solid, but it's still very, very fluid and deformable. This olivine has that type of typical property. Okay, so when you apply pressure on this, olivine ऐसे खुल के फैल जाएगा. Remove the pressure, olivine again becomes solid. It's capable of deformations because of pressure. Because of this, we say the lithospheric blocks are floating on the asthenosphere. Asthenosphere is supporting the above layers of the lithosphere. Olivine is the mineral, peridotite is the rock. भूमिका, olivine mineral है, और olivine mineral किस rock में है? It is in the peridotite rock. Yeah, fine. ये mistakes होंगे आपके. Rock कौन सा है? Okay, कौन सा mineral है? You'll confuse. No worries. You make your mistakes, I'll be there to rectify you if required. They all are measured from the surface of the earth. Okay, देखो, surface का मतलब कौन सा है? Ocean वाला या continent वाला? I'm saying, look at the thickness, 400 किलोमीटर. 400 किलोमीटर में 10, 15, 20, 30 कुछ मैटर नहीं करता ना. Okay, so whether you take it from here or here, okay, it doesn't matter much. And as it is, I'm giving you a range here. 300 से 400 बता रहे हैं आपको. So you just say surface. It does not matter you're measuring from the continents or the oceans. Okay, 400 नहीं होगा तो 420 हो जाएगा और क्या होगा? Okay, 300 नहीं होगा 280 हो जाएगा. So that's not an issue. On average, we say measured from the Earth's surface, And remember the range of the depth. Okay, 300, 400. Some books they'll mention 350, 375. Doesn't matter. You remember in terms of the broad range of the numbers. All fine here? Any doubts you have to clarify with me? Online, offline? Anybody? Difference between magma and lava. Magma is molten rock that stays inside the earth. Lava is the molten rock that comes out. Agar bahar aa gaya, okay, it's called as lava. If it stays inside, it's called as magma. Dunite is one type of rock found across the mantle. Okay, it is a form of peridotite. Okay, just no name to add to your diversity of your points. That's all. One type of rock of the mantle is called as dunite. Okay, let's move on then. Now, quickly, we'll discuss the conditions of the interiors. Conditions of the interiors. What is that, Dikshita? समझ में नहीं आया. What is OC? Ocean crust. Outer core, because it has high amount of silicates. The silicates impurities will lower the melting point. Asthenosphere is part of the mantle. It's part of the mantle. No, इतना काफी है भूमि का. What book to follow, I'll let you know. आज ही बता देंगे आपको. Otherwise, stick with the class notes. Okay. Conditions of interiors, you take it down as points. The first point I mentioned is that the Earth's interiors is layered. Earth's interiors is layered. And now you know the layered can be studied in terms of chemical composition. The layers can be studied in terms of what is their phase or what is their state, and we can study in terms of rocks and what are the minerals. Okay, in terms of chemical compositions, okay, say silicate hai, is it magnesium, is it iron, and because of it, what is its density? Okay, phase, is it liquid phase, is it solid phase, is it semi-molten phase? So the Earth's interiors are layered. Now, one point I will add here, that there are many theories in the origin of the Earth. Ye Earth bana kaise hai? Okay, some of which you might have heard. One is called as the Big Bang theory. Okay, so there is one theory called as the nebular hypothesis. The nebular hypothesis. That Earth was a nebula, not just Earth. Our universe maybe was a nebula. Our solar system was a nebula. So what is a nebula? A nebula essentially is an ancient formless cloud of dust, of gases and other building blocks. Okay. So nebula is an ancient, a formless, कोई shape नहीं होगा. It's amorphous. It's ancient. It is formless cloud. Cloud of what? Cloud of dust, cloud of gases, and clouds of other building blocks. So there are a lot of debates about what is the fundamental particle that makes up our universe. If you have heard terms like neutrinos, there is something called as Higgs boson particle. There's dark matter because हमें पता नहीं है वो है क्या. Dark in that sense. So there are a lot of other building blocks, a lot of other fundamental particles that make up our universe. So all that मिलाकर we call that as a nebula. And this hypothesis says, that the ancient nebula, it cooled, it contracted and it accreted. Accretion का मतलब होता है become solid. The ancient nebula, it cooled. The ancient nebula contracted, means it became smaller. It contracts. It accreted and it solidified into the heavenly bodies. The nebula, which is an ancient cloud of dust particles, वो ठंडा हो जाता है. It comes together, becomes solid. It undergoes a process called as accretion. Accretion का मतलब होता है it becomes solid. It accretes and it solidifies into heavenly bodies. So be it stars, be it the planets, be it the asteroids, सभी इसी से बनते हैं. Now in this process, okay, in the nebular accretion process, okay, it undergoes a density stratification. It undergoes a density stratification in the nebular accretion process. In the nebular accretion process, the nebula undergoes the process of density stratification. What's the meaning of what stratification? It becomes layered. Okay. And it undergoes what's called as gravity collapse. It undergoes a density stratification and gravity collapse. Now, gravity collapse mein, the process is whatever is heavy, it will fall inside. What is lighter will remain outside. So the heaviest matter will become the core. A bit less heavy will become the inner mantle. A bit less heavy will become the middle mantle, the outer mantle, the crust, and then the atmosphere. We call this as density stratification. We call this as gravity collapse. So this results in, okay, results in a density layering where the densest matter, rocks, okay, form the core. This results in a density layering. Keep writing, please. This results in density layering, okay, where the densest matter, the densest rocks become the core, and the progressively lighter rocks, the densest matter becomes the core, and the progressively lighter matter forms layers outwards. The progressively lighter matter forms the layer outwards. Okay, so I have the central core, then we have the inner mantle, then we have the middle mantle, then we have the outer mantle, then we have the crust, और सबसे बाहर है आपका atmosphere. The gases, they form the atmospheres. So this is how the Earth's interiors got layered into zones called as crust, mantle, and the core. All fine, all of you? So our discussion point essentially was that Earth's interior is layered. This was the important aspect of, okay, yes, so how did the Earth form? How did the universe form? It is not answered convincingly. बहुत सारी theories हैं. But if I look at the density stratification, we say this looks like that the most probable process must have been the nebular process of accretion. I'm not saying कि बाकी नहीं हुआ होगा. I do not know. But looking at the density layering, the most convincing theory looks like nebular hypothesis, but then there are many other aspects of our universe which the nebular process can't explain. So here within bracket write one sentence right down. The density layering indicates that the nebular process or nebular accretion process, the nebular accretion process must have been the more likely process. The nebular accretion process must have been the most likely process in the origin of Earth and solar system. But not all aspects of our solar system, can be explained by the nebular theory. Not all aspects of our solar system or the Earth can be explained by the nebular theory. So there are other theories like a planetesimal theory, the Big Bang theory. We have the tidal hypothesis of Jean and Jeffreys. We have binary star theory. बहुत सारी theories हैं. You don't need it for optional. Maybe when you're doing GS, some terms we'll give you. Otherwise, we don't need this for our optional geography. Okay? So that's one aspect of interiors, that the interiors are layered. Okay. The second point is that the interiors are largely solid. The interiors are largely solid. Okay. But parts of the mantle, okay, the crust and the core are also in the fluid form. The state क्या है? State is that much of the Earth's interior is solid, but parts of the mantle, parts of the crust and the core are also in the fluid form. Okay, it's fluid form as in it can flow. And the fluid form is partly because of very high temperatures which can melt the rocks. The fluid form क्यों होता है? Partly because of the high temperatures which can melt the rock, and also because of silicate impurities which can lower the melting point. Also because of the silicate impurities which can lower the melting point. So something which has a lower melting point will melt faster. Something which has higher melting point, जैसे अगर iron है, say iron melts at temperature T centigrade. Iron में अगर आप डाल देते हो, impurity डाल देते हो, then iron plus impurities can melt at less than T temperature. When you add something which is like impurity, it can change the melting point of that substance or that rock. Okay, so the example of this is, I said, look at what's happened to the outer core. Outer core is fluid because it has a lower melting point, okay, compared to the inner core. Okay, so this is one aspect of interiors. It's largely solid. And one more point I added yesterday, that the mantle, because of a high heat, okay, parts of it are molten and they flow as convection currents. The mantle, because of the high heat, parts of it is molten and it flows as convection currents. It's when I use the word convection current, I basically mean there's some kind of circulation going on. Okay, this is the mantle. Okay, now this is molten. The molten mantle doesn't stay here. It circulates. It rises. It diverges. It sinks, and it comes back and joins. It rises. It diverges. It sinks. It comes back and joins. And that's how this circulation happens. We call this circulation as mantle mantle convection cells. It's like, if you know about a room, if I have a heater, okay, the air can become warm, air can rise up, air will spread out, air will cool, come and sink again back toward the heater. And that's how the convectors will start circulating the air. Okay? So the parts of mantle are molten and they move. Okay, and they're called as convection currents. And at a point here, the convection currents are very powerful. The convection currents are very powerful, capable of influencing, capable of influencing how the crust above the mantle, behaves and moves. How the crust above the mantle behaves and moves. ठीक है, ये जो band of molten rocks are moving, it's a very powerful system. So if there is some crust here, okay, this crust can also get pulled. If there are some continents or oceans here, because of this convection current, even this can start moving. Okay, and that's how we have all the phenomena of the plate tectonics. The convection currents are capable of influencing the crust on top of the mantle. They can move, they can collide, they can get crushed, they can develop cracks, faults, and we have the entire plate tectonics because of this. At a point that this concept is the basis of, the plate tectonics theory. This concept is the basis of plate tectonics theory. Okay? Okay. So the third point now. Now talking about the temperature conditions. So I've talked about layering. Okay. I've talked about the state, kahan par solid hai, kahan liquid hai. The third condition of interiors is the temperature conditions of the interiors. So important point to understand that the interiors of the earth, okay, they are very, very hot. ये heat आया कहां से है? Okay, this hot, the source of heat, the source of the internal heat क्या है बताओ? Okay, there is two sources of the heat. Yes, Dikshita, you are right. Okay, my suggestion to all of you, I am sure you have heard quite a bit of this. You know continents move. You have heard about, okay, the word called plate tectonics. My request to all of you is, अभी मतलब मत करो. जानते हो अच्छी बात है, दिमाग में रखो कि हाँ मुझे पता है. Okay, लग रहा है सर ने पैसे बेकार ले लिए मुझे, ये सारा मुझे पता था. Okay, keep it aside. Move at the pace I am moving. After 2-3 days, okay, you will learn to respect me a bit more. ठीक है? So अभी क्या ना मडल हो जा रहा है. कि सर वो ऐसा थ्योरी है क्या, वैसा थ्योरी है क्या? I know that you know. Okay, but hang on, there are parts that I know you do not know also. तो ठीक है, good, nice. So the source of the heat, one is, it is what's called as the residual heat. As in, remember we talked about the nebula? Nebula is what? The ancient gas. And that was very, very hot. Slowly, gradually, that nebula has cooled, the nebula has contracted and become solid. But फिर भी, there's some amount of heat trapped inside. So the earth has not cooled completely. We call that as the residual heat, or some books might write that as a residual gravitation heat. Even if the whole thing has collided, accreted, okay, but अंदर कुछ बच गया है. This is, okay, one source of heat, the residual gravitation heat of the interiors. Okay, this is the remnant of the nebula which was once very, very hot. This heat is the remnant of the nebula. The heat is the remnant of the nebula, which was once very, very hot. Like that's one source of heat. Another source of heat is the radioactivity inside the interiors. There is a radioactive fusion going on, a radioactive disintegration going on. There is uranium type of minerals. So internal part of Earth also has a radioactivity in the interiors of the Earth. Okay, these two things are responsible for the heat that we have inside the Earth. Okay? So part of it is residual heat, part of it is the radioactive heat. Yes, I'm glad you know that. Basically, when something is accreting, one important process in the accretion is the process of fusion. Okay, so when two molecules fuse, okay, I mean this is some bit of Einstein's relativity. Okay, when you fuse, okay, some amount of mass gets converted into heat. Okay, that's what's called as the mass defect. ठीक है, इतना दूर नहीं जाएंगे. Okay, we'll keep it simply as this. It is the part of the process of the nebular accretion itself. That's why I said it is the residual heat when the Earth was forming from the nebula. ठीक है, Earth is hot. Now, what is the pattern? Interior of Earth में ये temperature को कोई pattern है या random है? Okay. Now, the pattern is for the initial 40-50 kilometers, sometimes even up to 100 kilometers tak, okay, the heating is at the rate of 2 to 3 degrees centigrade for every 100 meters. For the initial 40-50 kilometers, for the initial even up to 100 kilometers tak, the rate of heating is approximately at the rate of 2 or 3 degrees centigrade for every 100 meters of depth. Up 100 meter jao, it will become 2 degrees warmer. Go another 100 meters, becomes another 2 or 3 degrees warmer. For the initial 40-50 kilometers, or even up to 100 kilometers, the warming ka jo pattern hai, it is 2 to 3 centigrade for every 100 meters. Okay. Thereafter, there is no particular pattern in the heating. Thereafter, there is no particular pattern in the heating of the interiors. उसके बाद depend करता है भाई जहां पर radioactivity है, the area becomes more warm. Where there is no radioactivity, it is relatively cooler. So beyond this depth, there is no pattern. However, okay, locations which have very high tectonic activities. Locations which have very high tectonic activities, the temperatures is approximately around 1000 degrees centigrade. Where we have very high tectonic activities. Something is happening inside. You'll talk about what is collision of the plates, what is the divergence of the plates, where there is mountain building going on, कि fold mountain बन रहा है. Wherever we have tectonic activities, okay, which is, okay, there is plate interactions, okay, where there is mountain formation happening, okay. Those areas can have temperatures at around 1000 degrees centigrade. जैसे आपने सुना होगा, if you have been Himalayas, parts of Manali has lot of hot springs. Okay, so that's an area. Why? Because वहाँ पर collision हो रहा है. So those rocks are relatively warmer. We call that as, yeah, they are called as the geothermal energy locations. Correct. So we have one plant called as Manikaran, okay, near Manali, where we have a geothermal power unit also. So those areas can have higher temperatures. Then deeper mantle at depths around 500 kilometers, at depth around 700, 1000 kilometers. Okay, the temperatures the temperatures can be around 2000 to 4000, sorry, 2000 to 3000, 3000 centigrade. In the deeper mantle, okay, in parts of depth at around 500 kilometers, 700,000 kilometers, okay, the temperatures can be around 2000 to 3000 degrees centigrade. Okay, then if we go as deep as, the core mantle boundary, the temperatures can be again at around 3000 centigrade. At the core mantle boundary, the temperatures can be around 3000 centigrade. Your books may, they give you 2900, 2700. I round this off for convenience ताकि आपको याद रहे. Okay, and at the core, this is the core mantle boundary. At the core, the temperatures can be around 3000 to 4000 centigrade. At the core, the temperatures can be around 3000 to 4000 degree centigrade. How do we know the temperatures of the deep inside Earth? किसी ने, okay, for the sake of knowledge, he must have sacrificed himself. Okay, so with all due respect, जाके देख क्या होगा temperature लेके, okay, कि दोस्तों घर वालों मैं जा रहा हूं. Rahul, how they know, I do not know. But I want to believe whatever they say, सही बोल रहे होंगे. Okay, so कुछ चीज छोड़ दो जियोलॉजी के लिए. ज्योग्राफी में इतना पढ़ के आगे निकल जाते हैं. ठीक है? This is always a question. How do we know that? How do we know that? पहले रैंक ले आते हैं, एग्जाम कर लेते हैं क्लियर, then we can talk about it. ठीक है? तो अभी भी एक्सेप्ट. ओके, हाँ, जो नहीं आता, पंकज वेरी राइट, चुपचाप रट्टा मारो, मेमोराइज एंड मूव अहेड. बड़े बुजुर्ग ने कहा है, सही कह रहे होंगे, करेक्ट. Okay, so you know the earth is layered. Now your question is valid. I'm always happy when you ask why, but I'm unhappy when you want the answer right now. Okay, why तो होना चाहिए, हर चीज के लिए why पूछा करो, why this, why that, but answer को बाद में लेना, अभी syllabus वाला है. ठीक है? So I'm done with the patterns of temperature. Now, just for sake of some additional content, what are the various models and what are the various schemes, okay, detailing the interiors of the earth? What are the models? What are the schemes detailing the interiors of the earth? This is an extra content. You may not need it, but it's no harm in knowing few facts more. The thickness of the asthenosphere, Eshan, is below the lithosphere, so about 300, okay, 200 kilometer है thickness. The first 100 is lithosphere, and उसके बाद 300-400 तक it is asthenosphere. Okay, so upper mantle का lower part. ठीक है? So what are the models? What are the schemes detailing the interiors of Earth? So यहाँ पर the more modern and the more contemporary scheme, ये हमने कर लिया. We have a model for a chemical layering and we have a model for mechanical layering. Chemical layering model says crust, mantle, core, and the mechanical model says lithosphere, asthenosphere, mesosphere and barysphere. This is the more contemporary one, which is what we need for all our studies. Iske alawa, there are couple of other models also. The other models, okay, the other models, we will take it down like a table. Okay, so don't write now. Don't write now, wait. I'll give you the details. आप इसको लिख लेना. One of the oldest model was given by Edward Swiss. Don't write now. First listen to this, then you can draw better. So there is a outer layer. They have talked about an intermediate layer, and they have talked about the deep and the core. The deep and the core. So this model is what, and remember, other models, they are all outdated. Today we say they are not the ones we follow. But a lot of these models ultimately inspired what we have and what we know today. So Edward Swiss ka sabse popular you all have heard about. There is a layer called as Sial, the layer called as Sima, and the layer called as Knife. Okay, this was the oldest model. Okay, the Sial basically means silicon and aluminium. Sima means silicon and magnesium. And Knife is nickel and iron. Okay, this was the idea. And the Sial layer is only the continents. This is absent at the oceans. The density is approximately about 2 to 3. And this layer has a thickness of 60 kilometers, approximately 300 kilometer tak. It is the thickness, the Sial layer. And the Sima layer is the oceans. The Sima layer is the mantle also. The Sima layer has a density of approximately 4 to 5, and this has a thickness of 1000 to 2000 kilometers. And the Knife, the deepest part, this is the core. This is rich in nickel and iron. It has a density of 11 and more, and this has a thickness of approximately 5000 to 6000 kilometers. Okay? So, likho now. Yeah, I'll repeat. Edward Swiss model, one of the oldest models we have. He talked about an outer layer. He talked about an intermediate layer. He talked about a deep and the core. The deep and the core. And remember, all these numbers I am rounding off. Ab kitab kholenge likha hoga 2.9 likha hoga. Okay, I have put it as 2 to 3. Okay, kitab khologe, okay, 70 likha hoga, 50 likha hoga. I am rounding this off, so that you have the repeat of numbers to remember better. So what is Sial? Likho, Sial is only the continent is Sial. The Sial layer is missing at the oceans. It is absent at the oceans. It's missing at the oceans, absent at the oceans. It has a density of 2 to 3. It has a density of 2 to 3. A thickness of 60 kilometers to 300 kilometers. Thickness of 60 to 300 kilometers. The Sima is the ocean. The Sima is the mantle. The Sima has a density of 4 to 5. 4 to 5, and it has a thickness of 1000 to 2000 kilometer. 1000 to 2000 kilometer. And knife is the core. Knife has a density of more than 11. And it has a thickness of about 6000 kilometer. Thickness of about 6000 kilometer. या thickness का मतलब होता है अभय, दिमाग ज्यादा चल रहा है आपका. I will not repeat what you have said, but I get your point. Okay. लिखा आपने all of you done? See, what he is saying is this. This is the earth. Maybe this is the outer layer. This layer. This is जहां पर सियाल है. Okay. And then this is the ocean. Another Sial continent. And then the ocean. So this is Sial. This is Sima. This also is Sima. Okay. So where the oceans are there, there's no Sial. This is the ocean. And another Sial is here. Okay. So wherever the continent is not there, okay, there we have only Sima. The thickness of this he has mentioned. The thickness of this he has mentioned. This is the center of Earth. This is the thickness of the core. Not the radius alone. So अगर आप देखोगे, okay, the radius of Earth is, okay, 6,4. If you know this value, Earth का radius कितना है? 6400 kilometers. Radius of Earth. Where does the core start? Around 3000. Isn't it? तो ये कितना हुआ आपका ultimately? 3400. This plus this is approximately 6000, 7000 kilometer. Okay, he's talking about thickness of the core. Thickness core का मतलब है, okay, the diameter. ठीक है? So when you asked me, sir, अगर अर्थ का रेडियस ही इतना है, so how can the knife be so thick? Okay, knife is the complete diameter. जो वैल्यू लिखा है मैंने, ये complete diameter है, not only the radius. So calculate and see if you can understand this. So this is approximately 3000. 3000 is a 6000. The thickness of the knife. ठीक है, तो आप इतना याद रखो. That's about it. No issues. अच्छा, this is one model. There was another model. This was given by Arthur Holmes. Arthur Holmes. Again, a very famous physicist, geophysicist, Arthur Holmes. He says that the Earth has 3 layers. The outermost layer he called as the grandiorite layer. Then there is an amphibolite layer, and there is an echolgite layer. This man used 3 other terms. The outer layer was called as grandiorite, as in granite and diorite. Grandiorite layer. Amphibolite, the mafic layers, amphibolite layer, and there is an echolgite layer. Okay. Write down the details, लिख लो पहले. Grandiorite, amphibolite, and there is echolgite layer. The grandiorite, the outermost layer, it is the lightest, and approximately 10 to 12 kilometers thickness. 10, 12 thickness, kilometer thickness, and the density is less than 3. The density of this is less than 3. The amphibolite layer is the next layer, approximately 25 kilometers thick, and a density of about 3 to 4. So this is more like the continents. This is more like the oceans and parts of the mantle maybe. And iske baad mein whatever remains is they call guyite. They call guyite is the rest of the interiors. Density of more than 5. Rest of interiors, density is more than 5. Arthur Holmes model. Then we have a third model. Likha apna all if you done? The third model, this was given by Van der Graat. Van der Graat's model. CTH, Van der Graat's model. इसमें भी ऐसा ही है. There is a outer layer, there is an intermediate layer, and there is a deep layer. An outer layer, an intermediate layer, and a deep layer. Okay. Outer layer is outer silicates. The outer layer is outer silicates. Thickness of about 60 to 80 kilometers thickness. Density of less than 3. Density less than 3. This makes up the continents, and this is absent at the oceans. Outer silicates, density less than 3. It makes up the continents and absent at the oceans. जो intermediate layer है, इसके दो layer हैं. There is a layer called as inner silicate layer. The inner silicate layer. Okay. इसका property लिखो. This is approximately 60 to about 1,000 kilometers thick. 1,000 kilometers thick. This has a density about 3 to 4.75. Density of 3 to 4.75. And there is another layer called as the layer of mixed silicates. The layer of mixed, the outer silicates, sorry, intermediate ka inner silicates, and a layer of mixed silicates. Mixed silicates, this is beyond 1,000 kilometers. Okay, up to 2,900 kilometers. Beyond 1,000 up to 2,900 kilometers, and this has a density of about 4.75 say 5 tak. So if you look at the modern contemporary one, this one corresponds to the inner mantle, and this corresponds to the upper and the middle mantle. Okay. The mixed silicates correspond to the inner mantle, and this corresponds to the upper and the middle mantle. This is upper and the middle mantle. And then we have the third layer. Okay, the third layer is the core. The third layer is the core. Okay, it is beyond. This is beyond 3,000 kilometer depth from the surface. And this density is more than 11, and this is pure metals, mostly iron and nickel. Pure metals, iron and nickel. If you can see, Van der Graaf's model is closest to our contemporary model. Whatever we know today in terms of the core mantle crust, okay, whatever we know in terms of lithosphere, asthenosphere, ये सबसे पास उससे है. The closest one that we have in its approximations. I repeat, okay, this is beyond 3,000 kilometers from the surface, a density of more than 11, and it is pure metals, mostly iron and nickel. Iron and nickel. ठीक है? So this gives a sense of what the interiors are, what are they made up of, what are the properties, the conditions in terms of their phase, and what are minerals we have talked about. All fine here, all of you? I will want that you should get your textbooks with you, please. Not today. Next class onwards, you bring your book with you. Okay, Samindra Singh Geomorphology, and I will point out what pages you may look up from this. ठीक है? तो next class में किताब ले आना. After you have understood this, made your notes, you go back and add from that. The 3 layers of Holmes. Okay, Holmes talked about the layer called as grandiorite, the layer called as amphibolite, and the layer called as echolgite. The outer layers as grandiorite, then the layers amphibolite, and then the layers echolgite. ठीक है? Okay. So you just mention one point here, that Van der Graaf's model is the closest to, Van der Graaf's model is the closest to our contemporary understanding of the Earth's interiors. The interiors continue to be, the interiors of Earth, they continue to be not completely known. They continue to be not completely known, and we continue discovering the details with the advancement of geophysics. ठीक है? So that section ends. Take up a fresh page. Evidences of the Earth's interiors. So again, this is one topic many of you would have read as a part of GS maybe or NCERTs maybe. ठीक है? I'll help you revise this. और क्वेश्चन का पूछेगा तो my guess इससे पूछ सकता है, and they have asked questions from this in your GS paper. अच्छा, by the way, one improvement we have done is, all of you attending the classes, the next day, we share the class summary with all of you. So what I'm doing in the class summaries now on is, I'm attaching what are the questions asked in the previous years on this topic. And I will attach both the questions of GS and also questions of geography optional asked. Like yesterday's class, we attached that question, okay, what are the characteristics, properties of the primary rocks? Okay, some of which you may have read, others not read, but usko bhi dekh liya karna. So this topic again, in recent times, there have been no questions in optionals, but twice they have asked in your GS paper. Okay? Yes, Aman. So as we continue in our efforts, we try modifying and bring in some new things, so your study becomes a bit more conducive for you. Okay? So we go back and check. Okay. So answering your question, Rahul, आपने मुझे पूछा था, I laughed that away, but that was a relevant one. That's what we're discussing right now. How do we know about the interiors of the Earth? So what we know is that Earth's radius is about more than 6400 kilometers. It's a very large planet. Okay, Earth's radius is about and more than 6400 kilometers. We can access the uppermost and very superficial layers. Okay, just about 1 to 5 kilometers, 1 to 3 kilometers in the deep mines, and about 10 to 15 kilometers at the locations of oil drilling. Our Earth is having a large radius. Earth's radius is 6400 kilometers, and I have barely scratched the outermost layers. The deepest mines hote hain, they are generally within 1, 2 or 3 kilometers. So gold mines, some diamond mines. Okay, we don't go beyond this. Most mining is done within the first 200 to 300 meters mein hota hai mining. And in some places where we drill deep, okay, for oil, we go as much as 10 to 15 kilometers deep. If you know about this, in Russia, we have the Barents Sea. Suna term? Barents Sea is part of the Arctic Ocean. In the Barents Sea, for oil, okay, they have gone to almost 12 kilometers deep for oil exploration. That's all we can access directly, right? So much of what we know, what this means is that much of what we know about the interiors is by correlating other type of observations. Much of what we know, likho, much of what we know about the interiors is by correlating other type of observations. We correlate other type of observations. What are they? Okay, we study volcanic rocks, study of volcanic rocks. We can study meteorites. We can study the rocks at the deep trenches. So what we know about the Earth is largely by correlating other type of studies. हमने volcanic rocks देखा, volcanic eruptions are happening. So what all comes out tells me about what inside we must have. Okay. We study the meteorites. The idea is that the earth is made up of more or less the same rocks that make up the other planets also. The same rocks which are found in the meteorites also. So उसमें अगर हमें idea हो जाएगा what they have, I'll have some idea about what the earth is made up of. Okay, the study of volcanic rocks at the locations of volcanism, the study of meteorites, the study at deep trenches. So on the earth's surface, on the floor of the oceans, there are some locations, okay, where there are gaps. This is an ocean crust. This is also an ocean crust. If you know about something called as subduction, okay, तो यहाँ पर एक gap है. Okay, so there are ways by which I can study what is there in these gaps. These gaps are called as trenches. Some of you know this, others just get familiar. Okay, so trenches में I can observe in some ways what are the deeper rocks made up of here in the mantle. There's one place in southern Atlantic called as South Sandwich Trench. It is in southern Atlantic. In South Sandwich Trench, okay, this gap is a bit more. So we can actually see what's there in the outer layers of the mantle. When I see ऐसे नहीं कि झांक के देख लिया, they have got different instruments which can record some energy. Okay, yeah, so that's one location where they have studied the parts of the upper mantle. In this part, the upper mantle is actually exposed, and they study that. A place called as South Sandwich Trench. Okay, itna kafi hai. And then there are some studies called as gravity and density studies. Gravity and density studies. So I am not discussing these in detail, just mentioning the names, because we want a study which is called as seismic studies. These are more important. A seismic or earthquake waves study. So what we know about the interiors is by correlating some of the other observations. The other observations are a study of volcanic rocks, a study of meteorites, a study and observations at deep trenches, the studies called as gravity and density studies, and study called as a seismic or earthquake wave studies. That's what I was trying to skip. So what is density study? Okay, don't write it down. Just know this. Dekho. Simple logic. I have a mechanism by knowing what is the density of the earth. Kitna density hai earth ka? About average kitna hai earth ka? About 5.5 is earth's density. How we know it? Another story there. Like without going to Mars, I know what is Mars density. Without going to Jupiter, I know Jupiter ka kya density hai. So they have some techniques of knowing. The earth as a whole has a density of about 5.5. And we also know the outer layers continents is about 2.2. I know oceans are 3.5, which means what? अगर average 5 है और बाहर का layers 2 and 3 है, it means what? Interiors must be more dense. That's example of density study. Second, earth is spinning. Okay, and the spin of earth is very, very smooth. Okay, so density of the earth is about 5.5. The outer layers have 2, 3, 3.5 as density, which means the inner part must be denser. Otherwise, average 5 कैसे होगा आपका? then there are only two possibilities here. Earth here, and I have some rock, some large rock, some small rock. Density may be 10, maybe 3, maybe 15, maybe 7. The average of which is 5.5. That's one possibility. Okay. But if this is the arrangement of the rocks, then Earth will not spin very smoothly. Agar Earth mein the mass and the rocks are spread randomly like this, फिर Earth जो spin जो होगा ना वो smooth नहीं होगा. It'll start wobbling. Okay. Then we concluded it's not possible कि random होगा. The only way the Earth can spin very smooth is if the layers of densities are concentric and uniformly distributed. Only then will Earth spin very smoothly. Okay. And we know that this is possible if I take up the nebular accretion. This is what's called an example of density study. Let's say gravity. Okay. So you know that gravity of anything is based on the mass. So they have a mechanism of measuring gravity at different locations of the Earth. From the gravity, they know what can be the mass here, what can be the mass here, what can be the mass here, and so on. Okay, so we don't need the details. So I just have a passing reference that we also have gravity and density studies. That's all. Don't go into that route right now, not required. Okay. Let's start off with the seismic and the ये ज़्यादा important है. Okay. So give a heading. The seismic and earthquake wave evidences. The seismic and the earthquake wave evidences. Online, are you all keeping pace with me? Online? Yes? And offline, aap rakh pa rahe ho pace? Because I know I teach in different way. Some of you might be losing it, but then I make it a point to repeat everything that I tell you. And I also try to scribble something on the board just to ensure that you have a sense of organization. Okay. And what I scribble on the board is entirely my magnanimity. ठीक है? So इससे अच्छा हो नहीं सकता. आदत हो जाएगा. Of course करना पड़ेगा. अगर पैसे दिए हो तो पक्का होगा आदत. नहीं तो नहीं, you will एक डाल से एक और डाल जाओगे, कोई बात नहीं. Some of you are there, 2-3 of them I'm told that you are here for a demo class. So I put on a nice shirt today. Okay. I told my wife that I need to have a good ironed shirt. Demo लेने आ रहे हैं. जैसे लड़की देखने जाते हैं. Okay. तो आज कुछ लोग मुझे देखने आ रहे हैं. ठीक है? Let's show them 5 minutes. पूरा टाइम बचा है जान लेने के लिए, अभी क्यों? एक तो आज तक समझ में नहीं आया कि डेमो में क्या देखते हो. ठीक है, मतलब लड़की देखने जा रहे हैं, समोसा खा के आ रहे हैं, वो पड़ोसी हलवाई का होगा. ओके, सो आई डू नॉट नो व्हाट पीपल सी इन डेमो. ठीक है, बट एक ट्रेडिशन है. ओके, शुभारंभ करना है, श्री गणेश करना है, तो मुंह दिखाई तो करनी पड़ेगी. ठीक है, फाइन. And how do you judge a subject in 1 or 2 class? वो भी important है. Okay, you are studying a graduation level subject. 2 class में क्या जान पाते हो? What do you discover? Yeah? Okay, these are some questions I have in my mind. One of my ambitions is that I want to write a book on my experiences. ये सब important chapters हैं. Okay, demo class, and then I'll write something about it. अच्छा, so अगर you can't keep pace, please raise your hand. I will repeat it, but don't go back home frustrated. चला क्या बोलता है पता नहीं, कुछ लिखा नहीं जाता. ठीक है? So गाली वाली मत देना. Okay, we start off with the seismic studies. Okay, so now listen to this first. Whatever earthquakes we have, essentially earthquakes are what? They are vibrations, and in vibrations there is a release of energy. This energy is of different types. The energy can be heat energy, some amount of sound energy, some amount of electromagnetic energy, gamma rays, X-rays, ultraviolet rays, energy ka forms hai. Okay. And apart from this, we have some energy called as mechanical vibrations, or simply as mechanical waves hote hain. Okay. Now see, let me discount for now the heat and the sound. Isko chhod do aap. The electromagnetic radiations hote hain, the radiations are, I said, gamma rays, ultraviolet rays. The radiations can also be infrared waves, like what we get from the sun. These type of energy does not require a medium. Why? Because they are radiations. Radiations don't require energy, don't require a medium. But then there is some energy that vibrates the particles. We call that as mechanical waves. Mechanical waves can vibrate the particles, atoms, and molecules, and so on. What we know is that the type of vibrations that has a correlationship with what type of medium. For example, I have a medium called as glass, and I strike it. I can hear something. So the glass is made up of some material. If I apply a force, I can have some type of vibrations. The same force I apply on some other, say, wooden material, uska alag sound aayega. And that depends on the type of material. Agar wood hoga, X type of vibrations. Agar glass hoga, Y type of vibrations. If it is plastic, Z type of vibrations. Agar paper hai, maybe some other vibrations. So what we know is the mechanical waves are what? They are essentially vibrations of the particles and the energy moving through them. Energy moving through them. And the properties of the mechanical waves depends on the medium and the material that makes the substance. Okay? So we have one special type of waves called as mechanical waves. Mechanical waves, these require a medium to travel. They are unlike radiations. Radiations do not require any medium to travel. So when earthquakes happen, earthquakes में ये भी होते हैं और earthquakes में ये भी होते हैं. There are mechanical waves where the particles are vibrating. The vibrations of particles, and there are energy moving through the medium. And the properties of the mechanical waves. When I say property का मतलब क्या है? How fast is the wave moving? In what direction is the wave moving? Is the wave reflecting or moving ahead straight? Is the wave bending or not? All of those are the properties of the mechanical waves. So I have I have a body, say there is an earthquake here. From the earthquake, some energy is coming out. From the earthquake, some energy is coming out. Okay, energy is moving out here. Now, this energy, जो mechanical वाला है, it will vibrate the body. It will vibrate the body. And the property of this wave depends on what type of material. So this is one called as material M1. This is called as material M2. Maybe this is called as M3. So as the wave passes, the wave property in M1 is different from the wave property in M2 is different from the wave in M3. So there are mechanisms by which I can record these properties. And once I know the property, I know what type of medium it will be. जैसे कि आंख बंद करके, if I strike and it makes a sound like a ring, I know it is a glass. अगर glass होगा तब पक्का ringing sound आएगा. अगर wood है, it will be a very blunt thud. So I know अगर wood है, it will be a thud. Okay. So if I know the property in terms of how the wave behaves, I know what the medium will be. Okay. So there are mechanisms by which I can record these properties. Head down. Yeah, material means the entire earth, not just the crust. The material of the crust, the material of the mantle, the material of the core also. All of them together are material. Head down. Earthquakes are rapid shaking of the earth. Earthquakes are a rapid shaking of the earth, and earthquakes release different types of energies. Earthquakes are a rapid shaking of the earth, and earthquake release different type of energies. Different type of energies. Next point. The radiation energies do not require a medium, but there are mechanical waves. Which involve vibration of particles. The mechanical waves that involve vibration of particles of the medium as the energy passes through them. Okay. It is the study of such waves. And their behaviors. The study of such waves and their behavior that can tell us about the conditions of the Earth's interiors. That can tell us about the conditions of the Earth's interiors. I hope this is fine, all of you. I repeat, there is Earth. There is some location where, we have an earthquake. Because of the earthquake, there are different types of energy coming out. There are radiation energies coming out. And then there are special type of energy which we call as mechanical waves coming out. Radiation energy I ignore because radiation energy does not require medium. It can move independent of the medium. It can move without the medium. But the energy which are the mechanical waves, which are the mechanical waves. Okay, this includes vibration of the particles. Say if I strike, some energy moves which can vibrate the particles of the air. When I strike the board, some energy moves where the particle of the board can start, okay, vibrations. So I call those as mechanical waves, and the mechanical waves includes some particles vibrating. And the point here is how the particles vibrate and how the energy moves. That depends on what type of medium it is. The sound. Sound is a mechanical wave. How sound moves in air is not same as how sound moves in water. It's not same as how sound moves in iron or wood or some other material. Yes, radiation का भी impact होगा, Muskan, but I am not concerned. Why? Because the radiation energies cannot tell me about the earth. हमारे यहाँ पर what is my objective here? My objective is not studying earthquakes. My objective is, can I use earthquake waves to study the interiors of earth or not? So radiations are, okay, I'm not concerned about that. But the mechanical waves, they are our main interest. Because when the mechanical waves move, they can tell us about what type of material the earth is made up of. Okay, right, next. There are two types. There are two types of mechanical waves. There are two types of mechanical waves. One, there are surface waves, and one, there are body waves. Surface waves are those that move on the surface of the earth. They move on surface of the earth. Okay, we call them as surface waves. So to know the interiors of, and body waves are those which move through the body of the earth. That move through the body of the earth. Okay? So that's one type of classification. So for knowing the interiors, मुझे क्या पढ़ना होगा? Surface or body waves? Body waves. So surface waves move on the earth's surface. They cannot tell us about the interiors, but the body waves, they move through the earth's interiors, and therefore these are more important. हमें ये पढ़ना है. To know the interiors, I study the body waves of the earthquakes. One. Now there's one more classification. This is in terms of where they are. Again, there are two types of mechanical waves. This is on the basis of where they travel. This is on the basis of how the particles vibrate. Types of mechanical waves on the basis of how they travel. Okay, where they travel. And this is on the basis of how the particles vibrate. Okay, so यहाँ पर there are two types of mechanical waves again. Okay, so any wave is what? Any wave is essentially energy moving. Any wave is energy moving. Okay, there are two ways particles can vibrate. The particles can vibrate, okay, along the axis of the direction of energy propagation. Okay, it's like this. Watch, all of you. Energy is moving like this. The particles are vibrating, okay, to and fro, back and forth. Okay, they are moving back and forth. The axis of the energy movement hai, the particles vibrating forward and backward, and energy moves. The second type is energy moves like this. The particles can vibrate at perpendicular to the energy propagation. So energy is moving like this, the particle is vibrating up and down. Or energy moving like this, the particles are vibrating along the axis. Energy moves like this, the particles can vibrate across the axis like this also. So this or maybe across. In both cases, the vibrations are at 90 degrees to the moving energy. In this case, okay, the vibration of the particles are along the axis of the energy. Likho. One is the vibration of particles along the axis of the energy movement, and this is the vibrations of the particles perpendicular to the axis of energy propagation. Vibration of particles at perpendicular to the axis of energy propagation. ये दो तरीका होता है. We call these as longitudinal waves. We call these as longitudinal waves, and we call these as transverse waves. Okay. इसका अलग नेम है. These are also called as secondary waves or S waves, and we call these as the primary waves or called as the P waves. So mechanical waves can be surface waves, body waves. Mechanical waves can be transverse waves, longitudinal waves, also called as secondary S waves, also called as primary P waves. Okay? So if I have a guitar and I plug the string vibrates up and down, and energy seems to move ahead. So the guitar plucking is example of a transverse wave. Sound waves are like this. Sound waves mein the particles vibrate to and fro. Okay. So in transverse wave, if you know this, some of you with some bit of physics background, transverse waves have a crest, have a trough, have a crest, have a trough. They move like this. The longitudinal ones, the waves come together, the waves can be far apart. The waves come together, the particles, sorry, they come together or they can be far apart. We call this as compression fraction, we call this as rarefaction. So compression, rarefication, compression, rarefication. That's how the longitudinal or the primary waves behave, and that's how the transverse or the S waves behave. Right. So example of S waves is guitar plucking. The examples of primary waves is the sound wave. So आपको जानना ये था that for the study, write on two lines. For the study of Earth's interiors, okay, body waves are important. And the study of P and S waves. And the study of P and S waves. This is what we had to know. The rest is all part of a bit of understanding. They are mechanical waves, and how the P and S waves behave will tell us what the interiors of the Earth are. Next slide down. The P and the S waves have typical properties. The P and S waves have typical properties. Okay, आपको दो याद रखना है. So there are P waves and there are S waves. One is both P and S, their velocity is positively related to the rigidity of the medium. Both P and S wave में, for both P and S waves, their velocity is positively correlated with the rigidity of the medium. Which means what? More rigid, P will move fast. Less rigid, T will become slow. More rigid, S becomes fast. Less rigid, S also becomes slow. So more rigidity, more velocity. Less rigidity, less velocity. That's one. Then the velocity is also positively correlated with the density of the medium. The velocity is positively correlated with the rigidity of the medium, and the velocity is also positively correlated with the density of the medium, which means more dense rocks, more fast speed. Less dense rocks, less fast speed. Okay? Okay. A third point is, okay, P waves can pass through both solids and liquids. P waves can pass through both solids and liquids. Within bracket, in liquids, they can become slow. But S waves can pass through only solids. S waves can pass through only solids. They cannot pass through liquid medium. Isi pe they've asked a GS question on this. Okay, and one more you can add in general, that in general, P waves moves faster than the S waves. In general, the P waves move faster than the S waves. Yes, correct. Last year they've asked a question GS mein on the properties of the P and the S waves. Yeah. Acha, so before we wind up, okay, and this last exercise that we had, I'll suggest if all of you can do this, please. It's not compulsory, but if you can, it'll help me plan your preparation better. जो आप पूछते रहते हो कि what to do, what not to do. Is it visible from your desk, and can you scan this? That's better. There are 8-9 questions. If you can't access it from there, then maybe if you can scan from this sheet, can you pass it behind? I didn't get enough of them. Just scan and pass it on, please, if you can. Yeah, please. Can you pass from your side? Behind last में. Scan करके इसको pass कर लेना if you can. Yeah, between. There are 8-9 questions based on 15 questions. Okay. The rest could be part of your... See, to be very honest, I need to know your education background also. I need to know आपका writing skill कैसा है. I need to know whether you are comfortable with CSAT, answer writing, essays writing. Are you science background? Are you humanities background? And when did you start your GS preparation? And when you started your optional preparation also? Hopefully, it'll take you not more than 1 or 2 minutes. Okay, multiple choice questions hain. Just click and submit. पीछे अगर नहीं हो पा रहा है तो please take the QR code. And be honest, इसमें झूठ बोल के फायदा नहीं है. Whenever you began, and I given a range there, वो रेंज में नहीं आ रहा है तो जितना आसपास आ पाए और क्या. When did you begin? When is the course getting over? And some of you are self-preparing some things. Some of you have not done NCRTs, so say so. Some of you have done so, that's also fine. Ganesh, when did your actual topic start? There are two parts. One is initiation classes. The second is your actual oceanography or environment geography. Okay. So whenever your actual course started, वहाँ से approximately 6 months. So I think March, I think I had begun with oceanography शायद, if I remember right. Or was it climatology? I forget. October में climatology. As a matter of another 2 months, I'm done then. You have said fine. And another uncomfortable question is, what has been your graduation marks? Okay. See, the truth is, those who have been good students historically, they follow a method of study. It's not that they are God-gifted types. Some of them may be, but mostly it's about how they study. Okay. So people with better education backgrounds in terms of academic performance, definitely they have some edge over the others. अगर आप लोग के अच्छे मार्क्स नहीं हैं, okay, it's not always fate destiny. आप कुछ मिस कर रहे होगे. Maybe your study method was not what the examination required. So again, be honest there. So when I can address your concerns, I can put you in relevant cohorts then. I know it's uncomfortable. कितने मार्क्स हैं बताओ. Okay, but बता दो. Okay, it will not be for display at all. Okay, आपका कुंडली खराब नहीं करूंगा मैं. Okay, it's for my analysis, how to approach you. It's like if somebody has poor writing skills, he can't understand essays abstract, और उसके marks भी कम हैं. So you belong to a category where we must work differently with you guys. Okay, at least I can give analysis from my side कि आपको करना क्या होगा, भले आप मेरे साथ करो या ना करो. Have you all got the QR codes in the class? नहीं मिला आपको? हुआ नहीं? Scan नहीं हो रहा है. अच्छा. Can somebody pass me? हाँ, टेलीग्राम ग्रुप में भी है. Yes. ठीक है. देखो इससे ट्राई करो. If you can. Anybody else who couldn't scan the QR code? Why UPSC question taking more time? Abhijit, I didn't understand your question. Muskan, that I will let you know. I'll send my analysis to all of you. You fill in your marks or your answers. Analysis, I will do that and let you know. Abhijit, I didn't understand your question at all. Acha, okay, okay. You think what best suits you. Why UPSC is a very important question to ask. What motivates you? आप करना क्या चाह रहे हो? And I'm not surprised if there are some of you who are doing UPSC only because your parents want to do it. Okay, पापा नहीं कर पाए थे, तो पापा ने अपना बोझ आप पे डाल दिया. That's why, okay, fine, whatever attempts you have. Okay, whatever you can answer. Offline, all of you done? Acha, for tomorrow's class, before you come to class in the morning, do check whether I have the same time or I might delay the class maybe for half an hour. I have a meeting to attend. I had one last week. I couldn't change it. So before you come to class tomorrow, आप Telegram group में message देख लेना पहले. What time I am starting the class. Accordingly, you come to class. ठीक है, all of you? Okay, thank you so much. Revise and tomorrow bring your textbooks also. Samindra Singh, Geomorphology. अभी तो आप class notes ही करो. Tomorrow I'll consolidate all of that together. Have you been told case study for today? Yes? Then 2:30 you have your case studies. Workbook session बताया है. Okay, whatever they have told you. Okay. बताओ.
Longitudinal waves and transverse waves. The movement of the particle is always right angle.
किसमें?
Sir, longitudinal waves और transverse waves का जो movement होता है, वो particle के movement के right angle.
नहीं, longitude में तो along होगा ना.